Hey, Donovan Keith here. I'm the product manager for capsules at Maxon, and in this video, I want to walk you through how to create and manipulate arrays and also work with iteration in scene nodes. Now, this video is specifically targeted at technical directors, so I'm assuming you've got a decent level of prior programming experience, maybe something in Python or the like, and you understand what I mean when I say arrays and iteration. And if those words sound a bit like gibberish to you, there's a lot of other tutorials that are more artist friendly that I'd recommend you follow. For now, just go ahead and skip this video until those terms make sense to you. Okay, so for my technical directors out there, I'm going to be going over a few different techniques. How to build an array, so creating a simple array-like structure. How to transform an array, so taking a bunch of values in an array and making them larger. And let me just go over to my nodes layout here so that you can see sort of a rough preview of what's to come. So building is creating an array of individual elements manually. The scalar transform here, I am taking that sort of a pre-built unit array and then I'm scaling it by a larger value to create this larger set of positions. Iterate Collection is a technique that you can use for working with an existing array and then looping through all of its values, doing something with them. Range is a very low-level node that is equivalent sort of to, in a for loop for I equals 0, I plus plus, and all that. A symbol collection is how you can create your own arrays from calculated values. And map, where there isn't actually a map function or node in scene nodes, but there are techniques that you can use to effectively replicate a map. So how do you take one array of values and transform that into another array of values? Next up is the concept of filtering. So how can I take an array of values and filter that result in some way? Next up is the concept of reducing. How can I take, for example, all of the point positions, find the maximum value here, and sort of reduce all of these positions into a single value here, the bounding box maximum. And last but certainly not least is this concept of nested iteration. It's a particularly tricky thing to do in scene nodes, so we're going to go through this kind of step by step. But how would you create a nested array or a nested iteration and work with that? So with all of that sort of in mind, let's go through these examples one by one and build them up from scratch. So for build, let's go ahead and create a nodes mesh. I'm going to take my nodes mesh and bring it into my scene, and let's call this build array. And I'm going to double click in my node editor and search for build, and I'm going to drag out the build array node. So the build array node will create an array based on an element type. So that is the value, the type of the individual element. Most often you're going to be wanting to create points or an array of vectors, so change your element type here to vector, and what you're going to see is that we get these 4 elements by default. You can delete them with these little x's. You can add more as you like. So I'm going to create a square, so my lower left is 0, 0, 0. My lower right, let's make this 100 units, is 100 units over an x. My upper right is going to be 100 over on x, 100 up on y, and upper left is going to be 0 on x and 100 on y. So now I have got an array of values. I can go ahead and go to my port inspector. It's going to tell me not active, and that's because this is not connected in any way to my output here. If you want to quickly evaluate something like this, there's a trick you can do. You could, for example, create a cube and set the size equal to the count. I'm using a get count here of these values, and that's just going to force this array to be calculated, and you can see yep, we get an array with these values. If you want to inspect, you can right-click and choose the Data Inspector and see each of those values. But in order to see these values, they do need to be output to the scene in some way. Otherwise, they aren't calculated. And that can be a bit tricky to work out, especially with some of these sort of nested iterations we're going to get into later. So this is the build array. Let's just talk about another way to visualize it. I'm going to use the clone onto points node, and this will take an array of points, an array of matrices, or a collection of a matrix and colors, things like that, and it will allow you to clone something onto them. So I'm just going to clone a sphere, radius 10, onto this, and I'm going to connect it to my output by tapping Q. So I've now manually built an array of points. You can go in here, manipulate these as you will. This is helpful sometimes if you just want to set up some default positions. I like to build these with unit values and then transform them. And that's what I'm going to get into next, is this concept of a scalar transform. So I'm going to take my build array, I'm going to now call this Scalar Transform. And rather than building up this thing with explicit sizes, I'm going to build it up with unit values. So lower right is just 1 unit over, upper right is 1 unit over, 1 unit up, upper left is 0 units over, 1 unit up. So now I do actually have multiple spheres here. It's a little bit hard to see because they're bigger than the distance between them. But I can now take this entire array and I can transform it. And I can do that with a lot of what are these called scalar transformations. So scalar arithmetic allows me to work with an entire array. So I can change my operation here. Well, I guess I could start with add, change my type here to vector, put my array out into here, put my other array into here, and now every single value here is going to get this value over here added to it. So I can just sort of move this over. But if I were to change this rather from add to multiply, I could say 100, 100, 100, and now all of these are being scaled on X, Y, Z. And so that's something I like to do, is build something up with unit values and then use an array scalar multiply or the like to allow the artist to adjust the width, height, depth of a thing. So that's a scalar transform. That's taking an entire array and manipulating those values. Next up is the concept of iterating a collection. So once you've got an array of elements, how can you take those and then do something new with them? So I'm going to take the scalar transform that we just made, and I'm going to duplicate this, and let's call this Iterate Collection. So Iterate Collection will take a collection, and a collection can be an array. It can be something called an array collection. It could be a distribution. And it will allow me to iterate through all of these values. So if I search for Iterate Collection, drag this out, I'm going to connect my array to the collection input type, and you'll see that the type over here changes. I'm going to also drag out a distribution, like a linear, just so you can see that this is something called an array collection. It's got a bunch of different types. I'm going to add an iterate collection. And now when we unfurl this, we see that it's sort of broken it down into a series of sub elements: the matrix, the index, the ratio, the color. And that's because our distribution here is actually what's called an array collection, which means it's made up of a bunch of different subarrays, all of the same length. So iterate collection is a really useful node if you want to work with lots of values. Okay, so I've got my iterate collection. What I want to do right now is for every single one of these points, I want to offset it in Z based on its index. So what I'm going to do here is actually move this. Yeah, sure. Let's take our iterate collection, which is getting all of these point positions, right? So if I do my port inspector, it's not active. If I clone it, we see we've got all these. Turning off the previous one there so we don't get them mixed up. So we've got a value of 0, 54, 54, 62, and on and on and on. What I can do now is take each of these individual elements and add something to it. So I'm going to take arithmetic add. I'm I'm going to change the type to vector to match the type of this port right here. And I now want to add the index value of the element in the array. So this is going to be 0, 1, 2, 3. That I'm going to put on the z position here. And I'm now going to, rather than doing a clone onto points, I'm just going to do a transform. So we're just transforming a single element. I'm going to transform my geometry by this position and output that instead. Now, it's a subtle change. We don't really see much, but they are shifting a little bit on z. And I'm now going to scale the size here by the index. So right now, size is 0, but if I increase this, this is sort of that z spacing that we're now controlling based on the index of each element. So 0, 1, 2, 3. So one thing I want to call out is that we now are doing an iterate collection. There is this scope port that sort of open brackets, and it's not going anywhere. And that's a dangerous place to find yourself in. We'll be going over how to handle these open scopes shortly, but just know that you really, really, really want to avoid a situation where you've got an open scope like this. Because you've effectively got a loop going on, and if you connect this up with another node that's got a loop going on, and maybe even connect it to another with another loop going on, there's a chance that you could end up with dozens and dozens or many thousands or millions of values that you don't mean to create. So generally, once you start iterating something, you want to start tidying it up on the other end, and that's what we'll go over next. Shortly. Let's take a look at let's take a look at a symbol collection next, and then we'll take a look at range. So I've got my iterate collection. I'm now going to duplicate this, and let's call this a symbol collection. So what I want to do is tidy up this iterate collection by recombining these elements into a single array. So I can choose to assemble collection. The assemble collection has a matching port here, right? This sort of open curly bracket. This gets closed over here, so this is closing up our loop. And we want to assemble a collection of a specific type. Now, you can manually specify the data type here. And here we are specifying not the type of an element, but the type of the entire collection. So I go to here. I want to be making an array, so I'm going to structure array. And the type of this array, I mean, if I wanted to connect just the index, this would be fine, maybe as a float. But I want to connect the updated positions, and those are all going to be vectors. So I'm going to change my type here to vector, wire this in here, and now I'm creating a single array out of all of these individual elements that are coming out of the iterate collection. And rather than a transform geometry, I'm going to do clone onto points, which is built to handle an array like this. And this is visually identical. You're not really going to notice any difference, especially with a simple setup. But if you were, for example, building a complex, a custom modifier, and you're making that a node and then using that in a setup and using that inside of another setup, this open scope could really come to bite you in the butt. So you want to make sure that you're closing that scope with something like an assemble collection. Assemble collection is the most performant node for closing up a collection like this, but a little bit later on when we talk about nested iterations, we're going to find ourselves in a situation where we've got multiple scopes, multiple sort of open and close brackets in our code, and we want to unfortunately, we won't be able to use a symbol collection because it only, as of 2025.2, only supports a single scope input. So let's go to yet another kind of pattern here. So we've been talking about assembling collection. Next up, let's talk about range. So range is probably the most familiar way of looping or iterating, right? If you're coming from like a C++ background, for example, you would write a for loop with a statement like for I equals 0, I less than count, I plus plus. And that's effectively what we're doing right here. So the range is kind of that for loop. So it allows you to set a starting value for I, and end. So the starting value is I equals 0, right? The ending value is that sort of count. What is the maximum count here? 10, let's say, while I less than count. And then it's going to output an updated value for, I'm calling it I, but here it's called range. And that's kind of what's going on. So let's go ahead and build our own range from scratch. So I'm going to create a new nodes mesh, call this range. I'm going to add a range node. So the range node has got a couple of parameters. Again, start is that start value. End is the, maybe better to think of it as end before. So if we start at 0 and we end before 0, we haven't done anything. We haven't counted at all. But if we start at 0 and we end before 2, we go 0. Is that greater than 2? No. Okay. 1. Is that greater than 2? No. Okay. 2. Oh, that's greater than 2. So we've only counted 0, 1. So end and end. End before. I like to have a count slider to work with. So I'm going to double click in here and choose IO for input output count. And drag this in. Now I've got a little slider that I can use. Goes up to 100. Nice, easy range to work with. Next, let's just add a text, just so you can see what's happening here. I'm going to take my text, and I'm going to take the range, put it in the text line, and just output this. And so what we are seeing is that we are getting a bunch of values, all of them sort of colliding in the same thing. And we can take a look at our data inspector, and we see that we're getting all of these values as well. Now this is, as you can see, it is an open scope or an open iteration. We need to close this and do something with it if, for example, we want to turn this into a bunch of points. So if I want to turn this into a bunch of points, I can use an assemble collection. And I want to assemble structure array, replace basic vector. I want to connect my open to my closed scope here, and I'll just pipe this in for my x value. So the x position is now equal to the x value here, and I'm going to do a clone onto points. Here are my points, and let's just clone some spheres that are, I don't know, 0.5 units in size onto this, and then let's take a look. Very small, but we can see it. As I increase my count, my range goes up, and so forth. Now, I can adjust my starting range value. I could start at 1 or 2 or 3 or 4 and then count up from there. So that's a useful thing. Another really common pattern when you're working with ranges is to try and get a ratio, like a 0 to 1 value, that you can then use to scale some other number. So I might divide my range by my count, and that's going to give me a 0 to 1 value or something close to it, and then scale some other value. So maybe 50 by 50 by 50, I'm going to scale by that ratio. So we're getting a maximum of 50. So as we increase, we get more and more and more. And one thing I'll notice in the front view here is that that endpoint is sort of sliding. So something I need to do is, if I want a true 0 to 1 value, I need to take my count and subtract integer 1. And I like to label this count minus minus, plug that in right here. You might be concerned about divide by 0. C4D is going to automatically handle that for you, so you don't have to worry about that divide by 0. And now we've got that endpoint sort of pegged to the end there. So that is the range node and how you can use it to create something akin to a for loop or simple iteration of that sort. All right, we've talked about range. Okay, the next thing here, and yes, this is a kind of a power hour. We're doing a ton of stuff in a single video, and I'm going to be breaking it up into time codes so you can reference just the part you care about. The map allows you to take one sort of value and transform it into another. Now, we actually kind of just did a map in range, right? We took this integer value and then transformed it into a vector value. But I'm going to show you how you can do something like take the positions of something and then transform it into a color, let's say. So it's a pretty common pattern. You've got an array of something and you need to turn it into an array of something else. And here I'm taking the positions of my sphere, and then I'm remapping them through the bounding box to get a 0 to 1 value, converting that into a color alpha. That's kind of redundant because I'm then just piping it into an array, a simple collection that's collecting up a bunch of colors. So let's talk about how to build the map. So I'm going to add another nodes mesh. Let's call this map. I'm going to add my sphere. And I want to get the points or the positions of my sphere. I'm going to choose get positions. And it says geoproperty get and then parentheses position. So we know that's what it's going to do. And it's going to be searching for an array called PT. That's going to work most of the time. Every once in a while, you're going to get a geometry that doesn't have its positions array with the same name. You can just delete the name here, and it's going to do its very best to find the first logical positions array for you. So now I've got an array of positions, and I want to turn this into an array of colors. So I'm going to, let's just do the simplest thing we possibly could, which is to set color. I'm going to take my geometry, and I'm going to directly plug my positions array into my color array, and we'll just take a look at the result here. And it has transformed it, right? There's a one-to-one mapping here. There's no real transformation. If we take a look at the data inspector now, we're getting really extreme color values. And I want to map these to a 0 to 1 range. So to map them, we're going to iterate through all of these items, transform them in some way, and then collect them at the other end. So let's add an iterate collection. Let's take this collection and assemble a collection on the other end here. I'm going to change my data type here from nothing to array. And I want it to be an array of color alphas. This is a specific type that is expected over here. To determine that type, I can click on array and it says color alpha 32. So if I'm being really, really good, I'll come in here, array, advanced, color alpha 32. So it's an exact match. I want to connect my open scope to my closed scope. And then I want to transform my color here, or my value here into this. So I could just divide this vector, probably by whatever the radius is, which is like 50. Plug it in here and plug this in. And now I've got something much better. I've now got at least things in the visible range, but I still probably want to get something nicer for these negative values. And for that, I like to use a range mapper. And the range mapper can accept floats or vectors. It takes in an input value and then an expected range for values. So with a sphere that's 50 centimeters in radius, I would expect minus 50, minus 50, minus 50 to 50, 50, 50. And then I can map my output like this. And now we get what we expect. If I don't want to manually enter these values, I can use the bounding box to grab the minimum and maximum size or sort of positions for my sphere. And now even if I transform the size of my sphere, the colors are automatically mapping. So that is a map. This is a pattern where you're taking one thing, you're looping through it, transforming it into something else, and then collecting it in a type of a different type. Okay, so that is map. We are getting down to the end here, just a couple, 3 more. The next is something called filtering. How do you take a list of elements and then only return a subset of those elements? So the technique that we generally use is not, for example, like deleting or ejecting values from an array, but rather we just go ahead and loop through all of the initial values, perform a test, and then build a new array that doesn't include all of those values. And CNodes does a pretty good job of handling the memory on these sorts of things and doesn't create unnecessary copies unless it absolutely has to. So it's not as wasteful necessarily as it sounds. So let's go ahead and go over how to filter something. So I'm going to add a nodes mesh. I'm going to add a sphere. And we are going to filter out all of the point positions that are less than a certain value. So I'm going to get my positions. I'm searching for all of them, not just those with a name there. I'm going to iterate through my collection. So to filter a collection, you need to first iterate through it. Now you're dealing with a single element, and with that single element, you can start doing some calculations. I'm going to do a less than comparison. So is the position x less than, and we'll just use 0 to start. And now I want to build up a new collection. Now, up until this point, we have been using a symbol collection. And a symbol collection is great for assembling, arrays that pretty much exactly match the length of what's incoming. It's really efficient. It's fast. This is when you can get away with a symbol collection. This is what you want to use. However, it does not support a filtered input. For a filtered input, we are going to use the append elements node, and this allows us to build up an array one item at a time. So I'm going to change the type here to match the type I'm trying to create. So I'm trying to create an array of vectors. And I have the ability to plug in my incoming value. So I'm going to take this position of my sphere points. I want to connect up this scope. So we are saying that this iterate collection is going to be closed or collected over here with this append elements. Right now, it is collecting every single element, but I have the option of controlling how many elements it is going to add at this particular tick. And I can do that by adjusting my count. And I'm going to choose to take the result of this comparison, which is going to be true or false, 0 or 1, and use that as my count. So when the value is less than 0, we are going to keep it. And if it's greater than 0, we're going to not. And now let's go ahead and set our position, or let's, clone onto these points. So here are my points, and let's just clone some small cubes onto these points, maybe 5 by 5 by 5. And there we go. We are now getting all of the point positions from our sphere. We're taking that array, just the raw point positions. We're seeing any of them less than a certain value, and then we're creating a new array with a subset of these values. So that you can see these are all negative values. And I guess if we wanted, we could add in an IO size, something like that, and use this to control the sort of filtering, right? So that is how you can filter. So the pattern, again, is to use the append elements and this count to control whether or not a given element gets added. Next up, we are getting close here to some of the last sort of patterns that you're going to run into with iteration, is to reduce. How do you take a single, or how do you take an array and turn it into just a single value? And here we can see that in this reduce, I am taking all of the point positions of my sphere, and I'm turning them into a single value, which is the maximum x position, y position, and z position. And I'm not going to build this one from scratch. I'm just going to talk about it. We're taking our positions, and I'm using a node called array. There's lots of these different array nodes. Array component max from array arithmetic. So array arithmetic allows me to average a bunch of incoming elements, sum them, get the minimum component, the maximum component. So again, this will take this collection of elements and turn it into a single element. There's also a node called SumStream, and that will do the same thing, but rather than working with a completed array, it will do this with an iterate collection. It will take this value, or this, the open scope, allow you to choose what you're piping in there, and then it'll sum the values. It might do some other things for you. There might be like an average, right? The array average is some of these, excuse me, have different modes. There's all sorts of different sum versus array arithmetic and so on. There's another thing that we can do with something called loop carried value, but I'm not going to get into that in this video. It's a little bit more complicated. But these are the tools that are nice and easy for manipulating large numbers of values and turning them into one. So that is how you can reduce, kind of like boiling down like stock on the stove, reducing it down into a single value. Last but not least here, and probably the thorniest to explain, is something called nested iteration. So with nested iteration, we are, it's a pretty common programming pattern where you've got something like for, z in range 10, for y in range 10, for x in range 10. Let's do this, points equals this, and then you might do points dot append c4d dot vector x, y, z, something like that, right? So this is the programming pattern that we're going to attempt to replicate here in nodes. So I'm just going to copy this and create a new nodes mesh. Nodes mesh. And this I'm going to call nested iteration. And let's go ahead and build it. So I'm going to start by adding some input sliders for my 3 different counts. So IO count, and I'm just going to drag in 3 of these. 1, 2, 3. Count X, count Y, count Z. Next, I'm going to sort of reverse the order of these from what you might expect to be Z, Y, X. And that's because when you are drawing these in, you want to do all of the ones on the same Z level before you go back and do the next one. So Z, and then we're adjusting the Y, and then we're doing the X, right? So it's biggest change to littlest change is kind of how we're calculating this. So grabbing my nested iteration, I want to turn this into a range. So let's start with count X, choose range. For the end value here, we're now counting up to 3 or whatever this is going to be. And now at the end of here, I want to assemble a collection of vectors. And unfortunately, a symbol collection, as we talked about previously, does not allow for multiple scopes. That's going to give you weird issues. So we have to use append elements. I'm going to choose append elements. I'm going to change the type here to match what I'm trying to create. I'm going to try and create an array of vectors. Array, basic vector. And this is the X value. So I'm going to take the range, pipe it into X, and I'm going to connect this scope right here. And then I'm going to choose to clone onto points. And let's just clone a sphere. And I don't want to scale these values, so I'm just going to set the radius of my sphere to 0.5. And take a look at this. We are now controlling the number of spheres here with count X. Next up, I want to create another range. I'm going to go ahead and add a range. The end here is going to be count y, and I set y to this value. Now, if we're lucky, it's going to give us a single array, but as I look at this, we're not lucky. It's created 3 different arrays of length 5. And that's because these 2 ranges don't really know about each other. One is not leading the other. So Cinema 4D is doing its best to try and figure out, I don't know, how do I assemble these into something that sort of makes sense? And it's these sorts of things that really will often trip you up. So here we need to really explicitly say which range is controlling which and how and when they should all come together at the end. So I'm going to take this scope port right here, and I'm going to use it to control my range. I'm going to drag it on range, choose inputs, and set it to be this starting scope. Next up, I want to take this scope value. Let's just see the result here. We still have this thing of it being, these arrays like this. I now want to also have this scope sort of close at this append elements. And all of a sudden, we are now getting a single array of all of these elements in an order that makes sense. So we can just, if we want, just duplicate this range, count z over here, and do that same thing. This range to z, again, as we look at this, we're getting this, now it's arrays of 15. If we want to flatten those, we need this scope to control this. And we also need it to close over here. So this is the equivalent of 4z in range, 4y in range, 4x in range. And if this was C++, right, each of these would sort of have a curly bracket. And it would close, and you'd close the outer one and the outer one, and it would look kind of like this. And so close, 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 that's what's going on right here, these 3 little brackets. Right here at the starting point, this open curly bracket, that is also what we're seeing with the opening. So that's roughly what scopes are doing. It's maybe a little bit trickier than that, but that's my mental model. All right. That is my whirlwind tour. I'm trying to see if there's anything else here, of all of the sorts of things that you really need to do in a regular basis with loops and iterations in C nodes when you're working with low-level data, right? When you're building your own distributions from scratch, your own points and colors and so forth. More and more, this is not the case. You can use high-level nodes to set colors. So, for example, if we go up here to, I believe, the map example, right? We did this whole thing to map the colors of this sphere. We could also have just done set color and then looked at the result, and it is setting a different color for every polygon or even for every point here based on its position relative to its bounding box. And you can even do things like a random value and use a normal and sort of adjust the amount of blend. So I would say that the higher level nodes is definitely what you should use when you can. But if you need to do the low level stuff, you're going to need to do this sort of array manipulation, iteration, looping, and really, really, really paying attention to those scopes and trying to manage them. So yep, that is the intro. Please let me know if you've got any questions. This stuff can definitely be tricky. And hopefully this is a helpful reference for you to come back to when you've got a specific question about how to do some sort of typical programming pattern in C nodes.